All right, today we're doing logarithmic functions again, but this time we're going to look more at properties of logs. So eventually today, during the notes, we are going to simplify all 6 of these logs. There's 5 different properties, or 6 different properties, that we will learn that helps us to, again, simplify this either using exponentials or just rewriting it and simplifying it down to a single number. So the first property you want to write down is when adding logs with same bases, you're going to multiply their inputs. So down here, this is what it looks like without any numbers. So when my bases match, you're going to multiply your inputs. So notice here how I have m times n. So get this copied down. Your first example, again, I have log base 6 of 4 plus log base 6 of 9. Since my bases match, this tells me to just write it as log base 6, but then I have 4 times 9. So that's log base 6 of 36. From this point, this is just like what we did last class. Once you have a single log by itself, I'm going to rewrite it. So 6 to what power is 36? So this tells me that log base 6 of 36 is 2. Property number 2. It's the same idea, but when we're subtracting logs, we divide the inputs. So again, my bases match. So I took my 2 inputs and I divided them. So your example here, I have log base 5 and I take my 2 inputs. The first input always goes on top, the second input goes on bottom. So 100 divided by 4 is 25. So then again, I have to think 5 to what power is 25? And so again, this one simplifies down to the number 2. Property number 3. When the input is holding an exponent, you're going to bring the exponent down to the front of the log. Then you can evaluate like normal. So as you see here, I have an exponent of p. My input has an exponent. So the p I just make it bigger and it just gets brought down in front of the log. And it's the same as just multiplying p times that log. So here I have log base 2 of 32 to the 6th power. So I'm going to take this exponent and it's going to come down in front of the log. So I have 6 times log base 2 of 32. So I have to think I have 2, so I'm kind of ignore this 6 for now. So I'm just going to do 6 times, and I need to simplify this log to see what I'm multiplying 6 to. So 2 to what power is 32? So I know that 2 to the 5th power is 32. So it's really 6 times 5. And 6 times 5 is 30. All right, property number 4. So this is saying when your bases match. And when I say bases, I'm referring to the base of a log and the base of an exponential. So this type of problem is when I have logs and exponentials written together. Remember that logs and exponentials are inverses, which means they act just like adding and subtracting does, or like multiplying and dividing. Multiplying cancels out dividing. Adding cancels out subtracting. So this tells me that logs cancel out exponents, or exponentials. So if you see here, my 2 bases match. Here's my log. Here's my exponential. So since they match, they cancel out, and I'm just left with x. Same thing over here. It could be written this way. This time the log is up inside the exponential. But again, my bases match, so they're just going to cancel and leave me with what I was taking the log of. So I had 2 examples for this. So if I look here, I have log base 3 of 3 to the 11th power. Because these 2 match, they're going to cancel, and I'm just left with 11. This time it's written backwards. I have 4 as the base of the exponential and 4 as the base of the log. So the exponential and the log written together cancels each other out. So this only simplifies down to 7x. And that's all there is. All right, the last property you do need a calculator for. So what's going to happen So this is the only property that you cannot solve by hand or mental math. So if your base and your answer, which I've been referring to as your input, if your base and your input do not match, or there's no way to get them to match, then you're going to take log base 10 of the input and divide it by log base 10 of the original base. So, it sounds really confusing and looks really confusing, but all there is to it is we can say if B and A, if there's no way to get an exponent to get them to match, I'm going to break them up and do log base 10 of A divided by log base 10 of B. Because then I'm using 2 base 10s, so I can plug it into a calculator and just round the decimal. So here, 8 to what power is 32? So when I'm looking at this, I know that 8 squared is 64. So there is no whole number exponent that will get me 32. So this is where I have to use the change of base. So again, 32 is A in the example, and 8 is my base. So I'm going to take this and break it up and do log base 10 of my input and divide it by log base 10 of my output. At this time, you just grab a calculator and type in log 32 divided by log 8. And you should get 1.666666 repeated, so I'm going to say 1.67. Or just keep in mind when you type a log into a calculator, it's going to automatically open a parenthesis. So in the calculator, you have to make sure you close it before you type in the new one. So just make sure that your screen looks like that, to where you close your parenthesis before you start the new one. So those are the 5 properties you need to know to simplify these. So the try on your own, I have 1, 2, 3, 4, 5, 6 examples. So they're very similar to the examples you just did. So first you need to identify which property this is, and then use that property to actually simplify it down to a number.